Okay, so good morning, Boker Tov. My name is Arne Stoschek. I'm with Airbus Group. At Airbus, we build things that fly, airplanes, mention it, helicopters, space equipment. We look at societal changes and technology changes that would enable us new business opportunities. So one of the trends that we see is urbanization. So the world population, it's roughly 60% lives in cities, and there's a trend to ever larger cities, such as more than 30 mega cities with more than 10 million people worldwide. So how do people get from A to B in those large cities? There's a topic of commuting. So the commute time in average cities in the US, it's fairly long. So people spend an average more than an hour to get from A to B. So it's a lot of time, but it's also direct and indirect costs exceeding more than $100 billion in the US alone. How do people commute? So particularly in the US, it's mostly with ground-based vehicles, cars. And so just looking at the sheer numbers here, in the US we have about 260 million cars, so actually more than adult population, which is kind of mind-blowing. The cars are used fairly inefficient, and safe to state the ground infrastructure is at capacity. And so how can we deal with that? So we can build more ground infrastructure, but it tends to be very, very expensive and borderline impossible. So we can't build more roads. The opportunities to build more railway lines, that's all very, very limited. Then, so what options do we have? We can go down and build subways. That's a very successful model in some urban areas. It's very expensive. It's also very, very inflexible to add if you have change in population or the cities grow. The other option, they can go up. And I found this artist rendering, great idea. So it's not a new idea to think about an air taxi. What makes such a topic possible now? So a couple of core technologies, such as the availability of electric propulsion, then the availability of autonomous system, machine intelligence, and number three, the availability of low-cost electronics, both for systems like GPS, inertial measurement sensors, but also as a consumer-customer interface, such as with cell phones. The air taxi that we are building at Airbus is shown here. So we target low-cost urban mobility, low-cost at that price compatible with what you currently pay for taxis. We target a single passenger operation. It is self-piloted, meaning you don't need to fly or don't need a pilot to fly. And that basically dramatically reduces the cost and increases the flexibility how to use that. It's battery electric, and there's a lot of reasons, but the core reason is also safety that we have with distributed propulsion. We're looking at a range of roughly 100 kilometers to cover an urban area, and looking at a footprint of about 2 car parking spots. And a key part here is what infrastructure do we need to land this thing? So, and that's the vertical takeoff and landing capability. So that makes us independent of large airports. So why can't we use a helicopter? So helicopters are very inefficient in how they use energy, and they are also very expensive to operate. And why can't we use a traditional airplanes? Traditional airplanes needs an airport to land, and that's also something we can't do. So what we then do instead is basically look at a hybrid between a helicopter and a traditional plane. It's called a tilt wing. So we can use the flexibility of a helicopter and the efficiency of an airplane. How does it look for our air vehicle? That's a rendering of our vehicle in the kind of traditional plane mode. So it's a very efficient flight. It can move at roughly 230 kilometers per hour. Here I'm showing the configuration of the vertical takeoff landing. So it allows us to land in an urban environment, similar to what you can do with a helicopter. What ground infrastructure do we need? In theory, we can land on any hard surface. For a product rollout, we look at infrastructure that is centralized in urban areas. An artist rendering from Uber is shown here, so it could be on top of a garage, so in a transport center in vertiport. The key is we don't need an airport, and we are right next to other modes of transportation in the urban area. How do we use it as a customer? So the customer interface is to such a fleet is with a cell phone. And you can order such a vehicle, and the ground mode is shown here with ingress, egress. It's important to mention, though, we don't build this for individual ownership. This is intended as a fleet vehicle. How expensive is it, and how does it compare to other modes of transportation? At Airbus, we did a lot of studies. Other companies like Uber also did a lot of studies on time versus availability, cost, etc. And I was stealing from Uber presentation this chart here showing how do transportation systems compare, say, between San Francisco and San Jose. And what you can see here is an air taxi has the opportunity to be considerably faster compared to ground-based transportation, and surprisingly be very, very cost competitive with ground-based transportation. And yeah, I can go into great detail on the cost calculation here, but it's really the key. It's low-cost urban transportation. So where's this thing done? It's developed here in Silicon Valley. Airbus, we have several R&D offices and facilities, development facilities in San Jose and Santa Clara. So it's an in-house ground-up development. So you cannot buy that thing. So we have to do it completely ourselves. And we have a very interdisciplinary team of aerospace engineers, hardware engineers, software engineers to put it into reality. Then when can I get it? So we plan to have a first flying prototype available this year, so end of 2017. And we plan to have a productizable system available in 2020. That's also very soon. And then look at various topics related to rollout and certification. Last question is, how can you be part of that? So it's the Israel Dealmaker conference. Very interested in interactions related to data analytics, machine learning, deep learning, sensors, computer vision, data security. Yeah, please come and see me. Thank you.